Question number 1. In a solid AB having the NaCl structure, A atoms occupy the corners of the cubic unit cell if all the face-centered atom along one of the axes are removed. Then the resultant stoichiometry of the solid is A, AB2, option B, A2B, option C, A4B3, and option D is A3B4. Well, it is having an NaCl structure, so as according to the NaCl structure. So what we are going to have is, in this particular structure, let us consider that we have the A atoms. The A atoms, as what we have, these atoms are going to occupy the 8 corners, right? They occupy the 8 corners. As they occupy the 8 corners, hence their contribution is going to be as 1/8 of each of particles, right? So therefore, the complete contribution is going to be as 8 into 1/8, and that is going to be as 1. Now, let's proceed to our second one, as what we have is the face-centered atoms. So the face-centered atoms. Here we have these 6 face-centered atoms, right? Now each of them contributes, that is going to be half, because a particular atom that is on the face is shared by the 2 unit cells, and therefore the contribution is going to be as 1/2. Now, what we have is the total contribution made by these 2. Okay, so contribution is going to be as 6 into 1/2, and that is going to be as 3. So in this entire scenario, if we speak the total contribution of both of them, so the total contribution is going to be as equal to 1 plus 3, and that is going to be 4, right? So now, in this entire scenario, if we observe, if we have the B atoms, now the B atoms occupy the octahedral voids. Now, as they occupy an octahedral void, each of them contributes. Now, this is entirely happening for the B ones. Okay, so far we have spoken for the A, now for the B. So all of them are going to occupy the octahedral voids. So therefore, each of them contributes. Each of them is going to contribute. That is going to be as 1/4, each of them. So therefore, what we have is 1 plus 1/4 into 12, and that is going to be 4, right? So in this entire scenario, the formula is going to be as A4B4, or just as AB. But the condition that they have given is if the face-centered atoms are going to be removed. So when the face-centered atoms are going to be removed, that time what happens is removing all the face-centered atoms along an axis. So once we remove along an axis, that time what is going to happen is the total number of atoms removed are going to be equal to 2 in a cube, that is along an axis, right? So now, due to this particular thing, what is going to happen is the contribution of A, now it becomes as equal to 8 into 1 over 8, correct, plus 4 to 1 over 2, that is for the face centered, and the entire thing will become equal to 3. Correct, because we have removed 2 of them along the faces, right? So therefore, the entire scenario now is going to be equal to as 3. So now it becomes as A3 and B we have is as 4. So therefore, the option is D.